This video will go through the process of drawing the feasible region associated with a linear programming problem using the graph application of a Casio fx-CG50AU graphics calculator. This feasible region is bounded by three linear inequalities which will be graphed one by one. Launch the Graph app by pressing 5 from the main menu. To graph the first inequality, the type of graph needs to be changed from y equals, the default, to y greater than or equal to. To do this, press F3, then F6 for more options, then F3 to choose the required type of inequality. Now enter the expression for the inequality. Notice the symbol displayed, which indicates that the required type was chosen. The colour used to graph the inequality can be changed if the user wishes. I'm going to use the colours red, yellow and green for my three inequalities. To change the colour, highlight the inequality, then press Shift and 5 to access the formatting options. Choose line colour and then enter the number corresponding to the colour of your choice. Press Exit to accept your settings. The second inequality can now be entered. The type need not be changed for y2 as it is the same as the type for y1. To enter the third inequality, the type needs to be changed to y less than or equal to. Once done, the expression can be entered. With the inequalities entered, a sensible view window needs to be selected for their graph. For this problem, both x and y are between 0 and 100, as suggested by the third inequality. For the graph to have the same scale for x and y, a view window that is twice as wide as it is high needs to be chosen. This, along with the desire to see x and y axes on my graph, leads me to graph x from -10 to 210 and y from -5 to 105, with scales of 10 on both axes. Pressing Execute to accept the view window, and then again to draw the graph, we see the three inequalities represented as shaded half planes, and the feasible region as the overlap of the three. To get a closer look at my feasible region, I'm going to use a box zoom. This is done by pressing F2 for zoom and then F1 for box. Use the arrow pad to move the cursor to one corner of the rectangle that will enclose the feasible region. Once there, press Execute. Now use the arrow pad to move to the opposite corner of the rectangle and press Execute once more. The intersection points of the boundaries of a feasible region are important in linear programming problems such as this. I'm going to find the first intersection point by opening the GSolve menu, pressing F5. I now choose Intersect by pressing F5 again. I press Execute to select the first boundary, and then Execute again to select the second boundary. With that point noted, this same process can be repeated to find the second intersection point. This time, I'll use the arrow pad to select the third boundary. For the third intersection point, I'll need to use the arrow pad to make sure that the second and third are selected, pressing Execute to confirm each selection.